Before looking at the next conic shape, the ellipses, we're going to do a quick review of circles because they actually have a lot in common with each other. So here we have the standard form of a circle, including its two most important components, the center and the radius. Now we've already looked at parabolas in an earlier video. I've only included them again here for comparison purposes because I wanted you to notice things that they do and do not have in common with each other. They both use an h and a k value to describe what's usually the most important point on their shape. So the vertex is the h and the k, it's the number being subtracted from x and y for the parabola shape. And for the circle, it's the same thing. It's the number being subtracted from h and y, and this creates the very center of the shape. So this is not a point actually on the circle, it's just the point that kind of guides the shape of the circle around it. Also, you'll notice that we have a radius value, but do be careful and make sure you're always taking the square root of what you see there. They may write it as something like 3 squared, in which case 3 is r, or they may just show that the number is something like 16, in which case you have to remember to take the square root to find the radius from there. One of the other important highlights here is that you'll notice both x and y end up getting squared from these formulas. If you FOILed these two pieces out, you would have an x squared and a y squared term. But for the parabolas, you only have one or the other squared. You get x squared but y to the first power, or there's a y squared and an x to the first power. So sometimes you'll be asked to recognize which shape you have. That's one of the easiest things to check. X and y squared means a circle is a possibility. If you only have one or the other squared, it's a parabola. So there are two types of questions you'll get with working with the center form of a circle. They may give you the equation and then ask you for the center and radius, in which case you're just going to identify the number being subtracted from x and the number being subtracted from y. So remember, since this is a minus in the formula, that will change the sign. So if you see +2, then you write -2 here, and vice versa. And then the other piece is the radius. Again, if it says something like 5 squared, your radius is 5. If they just write a number like 16, take the square root of it to find that your radius is 4. There are some other questions that might make you work backwards. They may give you the center and the radius, in which case you just need to identify h, k, and r, and then plug those numbers in. So many questions will give you the circle in the standard form, in which case there's really no work to do. It's just compare it to the formula and identify h, k, and r. The tougher questions will not give it to you in standard form. You'll have to get it in the standard form yourself. So your first step would be to group the x's together. And I'm going to leave a space for completing the square in a moment. And group the y's together. And then another important part of completing the square is we want to move that constant to the opposite side of the equation. So since I have a -3 on the left, I'm going to add 3 to both sides to make it a +3. So since I have two variables being squared, I actually have to complete two squares on this formula. So first I'm going to do the completing the square for the x's. You take half of the middle number, which is -3, and you square it. So we decide to just randomly add this number. I know it seems random. I'll show you why we're doing this in a moment. Now I can't just add 9 to the left side of the equation without also adding it to the right hand side of the equation. So half of -6 was -3, squared is 9. We have just decided to add that to both sides. The reason will become clear in a moment. Now I need to complete the square for the y's. Half of the middle number is 2, squared is 4. I can't just add 4 to the left side of the equation though. I also have to add it to the right hand side. Now the reason we use completing the square on our x to the second power and y to the second power is because it lets us take this whole trinomial and factor it down so that this equals x and half of the middle number. Before we squared it, half of the middle number was -3, so it's this binomial squared. You can FOIL it out to check it, but that's why we added 9. It's so that this would factor down nicely to be x plus or minus a number squared. Same thing for the y's. The reason we added that 4 to both sides of the equation was because now if I write half of the middle number, so y plus 2 in this case, squared, this is equal to the trinomial I have here. So we had to add these numbers into the expression that we had into this equation so that these would factor down nicely. But to balance that out, we also had to add the numbers onto the other side of the equation. Otherwise, it wouldn't be balanced anymore. So I have 3 plus 9 is 12, and 12 plus 4 is 16. So this now matches the standard form of the circle that we had on the last slide. And when they say find the center and radius, well, the center is just the h and the k values. Don't forget to change the sign on these. So the number I'm subtracting from x is a positive 3, and the number I'm subtracting from y is a negative 2. So flip the signs on those 2 points, and then our radius is just the square root of that number on the other side of the equation. So in this case, the square root of 16 is 4. This is not a case where we're going to write plus or minus 4, because I'm not saying take the square root of both sides of the equation as an algebra step. I'm just saying what is the square root of 16? And the answer to that is 4. Now let me show you the way I take that information and draw the graph based on it. So the first step is to draw a dot for the center. So this is saying go right 3 and down 2. Now this will not actually be a dot on the graph. I'm just placing this for reference for the rest of my shape. The radius is 4. Now it's kind of hard to measure out exactly 4 going in diagonal directions, but it's not too bad to just measure straight up, down, left, and right. So from the center, I'm going up 4 units, and then right 4 units, and then down 4 units, and left 4 units. And then just do your best to make a rounded shape that passes through those points, and that will be your circle with a center of 3, negative 2, and a radius of 4. Okay, now let's do another example. Again, we're being asked to find the center and the radius, and then we're going to have to sketch the graph. It is not in standard form, so we'll get it into standard form first. So I will group together the x's, and then I will group together the y's. Notice I'm leaving that blank space because I know I need to fill in the completing the square part in a moment. And I'm going to move this 6 to the opposite side of the equation. Since it's positive 6, that means I'm subtracting 6 from both sides. Here is our completing the square again. Half of the middle number is 1. Squared is still 1. So add that to both sides of the equation, otherwise it is not balanced anymore. Half of the middle number is negative 3. Squared is plus 9. So add that number to both sides. That means we now have a factorable trinomial right here. It's always going to factor down nicely to be x and half of the middle number, or the p-value if you want to call it that instead. Same thing for the y's. For this trinomial, it will factor down to be y and half the middle number, which is a negative 3. On the right-hand side, I'm just going to be adding these numbers. So 9 plus 1 is 10, minus 6 is 4. So if they ask you for the center and the radius, just don't forget to flip the signs on the h and the k values. So h is negative 1, k is positive 3, and for the radius, if it had said 4 squared, my radius would be 4. But since this just says 4 with no exponent on it, I need to take the square root of that number, so the square root is 2. If you were working backwards, like I said, a question may give you the center and the radius. You're just taking the x, y, and radius spot, and you're plugging those numbers in. So don't forget to square the radius. Don't forget to write minus each of the h and k values. Flip the sign on them, basically. For drawing our shape, we're going to start with the center, which is left 1, up 3. So draw a dot lightly. It's not actually part of the circle. And then for a radius of 2, I'm going to measure 2 units up, 2 units to the right, 2 units down, and 2 units to the left, all from around that center. If your graph is going to be too hard to fit on the grid, remember you could change the scale. So instead of making each tick mark 1, 2, 3, 4, 5, you could change it and say that it's 2, 4, 6, 8, 10. If you change your scale to make the graph fit on your paper better, make sure you label it then. If I do not see labels telling me what the tick marks are, I'm going to assume the tick marks are 1, 2, 3, 4, 5 and grade accordingly. So now that I have those light dots around the outside, I'm just going to do my best to draw the curved shape going through those outside pieces. And that's it. That is our review on how to work with circles. If you like that video, be sure to hit like, subscribe, or comment.